Hi everyone, so we are back with another tutorial video, and in this video we will be covering the topic virtual warehouse of Snowflake. So virtual warehouse is a pretty interesting concept in Snowflake, and we can say that this is the muscle of the system. It is also an important layer in the Snowflake architecture. So we have already created a video, a full entire video on Snowflake architecture. So if you're someone who is new to Snowflake, you can go ahead and watch that video first. Pause this video, watch that video first, and then come back to this video. Okay, so virtual warehouse is the backbone of the Snowflake architecture, and it is also called the muscle of the entire Snowflake system. So in this video, we'll be covering the entire theoretical part on the virtual warehouses concept in Snowflake. So let's just get started. So the points that we will be covering in this tutorial are as follows. So we'll see what is a virtual warehouse in Snowflake. We will see the types of virtual warehouses available in Snowflake. We will have a look about what is the size concept in virtual warehouses inside Snowflake. We will also see the feature of auto suspension and auto resumption in Snowflake. And the most interesting aspect of this tutorial is the multi-cluster warehouse. Like, what is the multi-cluster warehouse in Snowflake? And post that, we will also have a quick look on how does a multi-cluster warehouse consumes the credits inside of my Snowflake ecosystem. Okay, so I hope you are excited to just learn this concept. So let's get started. So firstly, let's get with the definition of what is a virtual warehouse. So a virtual warehouse, it is often referred to simply as a warehouse, and it is a cluster of compute resources in Snowflake. So if you look in the diagram, we have a cluster of compute resources. We have a combination of multiple compute resources, and this cluster, it entirely makes up virtual warehouse. So this cluster of compute resources, it makes up my virtual warehouse. Now you might be wondering, what are compute resources? So a compute resource, if we talk specifically about compute resource, it is a combination of CPU, memory, and storage, temporary storage to be precise. So these three things, like the CPU, the memory, and the storage, when combined together, they make up the compute resources. Now, this definition would be a little bit more clear. So a cluster of compute resources is defined as a virtual warehouse in Snowflake. And a compute resource is a combination of CPU, memory, and some temporary storage. So now let's see a virtual warehouse. It provides the required resources such as CPU, memory, and temporary storage to perform few operations in a Snowflake session. So a virtual warehouse, it is entirely responsible for running up your SQL queries. Like whatever the queries you're trying to run, whether you are trying to load the data, whether you're trying to transform data, anything that is related to your database, to performing any kind of manipulation on your data, or either loading your data, that is done through a virtual warehouse. So let's see what are the operations that we can perform with the help of a virtual warehouse inside my Snowflake. So a virtual warehouse, it is used to execute SQL select statements that require compute resources like retrieving rows from tables and views. So whenever we try to run select statement on any single database inside my Snowflake, that requires a virtual warehouse. Also, we need a virtual warehouse to perform DML operations such as updating rows in a tables, like the delete operations, the update operations, or even the insert operations. So we have seen that whenever we try to run select statements, or whenever we try to run any kind of DML operations, we need a running virtual warehouse. And also for loading data into tables or unloading data from tables, we need a virtual warehouse. So these are the few points for which a virtual warehouse is required in a Snowflake session: executing SQL select statements, for performing DML operations like the delete, insert, update, for loading data into tables, and also for unloading data from tables. For these operations, we require some compute resources like the CPU, memory, and the temporary storage. And who provides all these compute resources? A virtual warehouse does. An important point to note is that to perform these operations, a warehouse must be running and in use for the session. And while a warehouse is running, it does consume Snowflake credits. So suppose if I am trying to load data from any Amazon AWS S3 bucket into one of my Snowflake tables inside any database. So for loading that data into my Snowflake table, I do need a running warehouse, and that running warehouse must also be in use for the session, which means it must be selected for the session. So without having any virtual warehouse running, we cannot perform any kind of operation on my dataset. So to perform any kind of data related operations like select or DML operations, we do need a virtual warehouse running and selected for a session. And we can also start and stop a virtual warehouse at any time depending on the user requirement. So suppose I will not be needing my virtual warehouse for another period of, let's say, 30 minutes. So in that case, I can just go ahead and stop my virtual warehouse, which will also save some credits for me. In the period that a virtual warehouse is stopped, it does not consume any credit. And also, a virtual warehouse can be resized at any time, even while running, to accommodate the need for more or less compute sources. So the concept of size in virtual warehouse, when we will discuss that, we will get into more details on this point, like how we can resize any virtual warehouse. But for now, just keep in mind that it is also possible to change the size of a running virtual warehouse. Okay, so what are the types of virtual warehouses in Snowflake? So we have two types of virtual warehouse available in Snowflake. First, we have the standard one, and then we have the Snowpark optimized warehouse. So let's see both these individual warehouses. So a standard warehouse is used to run normal queries on Snowflake. And whenever we have workloads or the queries that will not be requiring a huge memory requirement, so in those scenarios, we can go ahead with the standard virtual warehouse. And let's talk about the Snowpark optimized warehouses. So let's suppose I have a workload of any machine learning training use case. I have such similar use case dealing with machine learning or an AI model dataset. So in that case, I will require some more amount of memory, some more amount of CPU, etc. So in that case, Snowflake does provide us with the option to choose from a different category of virtual warehouse, which is the Snowpark optimized virtual warehouse. So these kind of warehouses are recommended for workloads that have large memory requirements. Okay, so I hope that the points were clear. Now let's move on to the next concept, which is about warehouse size. So a virtual warehouse, it is also defined by its size. And what does size mean in a virtual warehouse? Size specifies the amount of compute resources available per cluster in a warehouse. So in Snowflake, we have virtual warehouses ranging from sizes in the options of extra small, that is XS, all the way to 6XL, that is 6 extra large. And as we go on, as we move one level up in size, the consumption of credits also increase. So if we look into the screen, we can see the various virtual warehouse sizes, the options of various virtual warehouse size Snowflake provides to us. We have virtual warehouse sizes ranging all the way from extra small to 6 extra large. And also side by side, you can see the amount of credits per hour consumed by each. So for extra small, it consumes a credit of 1 per hour. Similarly, for small, it consumes a credit of 2 per hour. Similarly, a medium sized warehouse consumes 4 credits per hour, and so on. And the 6XL sized warehouse, it consumes a huge credit of 512 credits per hour. And also a point to note here is that the 5 extra large and 6 extra large virtual warehouse, it is generally available in AWS cloud providers only. So whenever I'm choosing AWS to be my cloud provider when I'm creating my Snowflake account, In those cases only, mostly I will be getting the option to choose a virtual warehouse of this size. And also it is in preview in US government and Azure regions. So this point is to be kept in mind whenever we are trying to create a warehouse of size 5XL or 6XL. But that is not mostly required unless we have a huge memory requirement. So mostly 3XL or 4XL virtual warehouses size is more than enough to deal with my workload, to deal with also huge amount of memory requirement workloads. In my virtual warehouses sizes, there is a doubling of credit usage as we increase the size to the next larger warehouse size for each full hour that the warehouse runs. So if I go back, we can see that extra small consumes a total of 1 credits per hour. And if I move from extra small to small, the credits per hour consumption also doubles. That is, it goes from 1 credit per hour to 2 credits per hour. Similarly, for medium, it goes from 2 credits per hour to a total of 4 credits per hour. So we can see that there is an exponential growth in the credits per hour and it is increasing in the double amount, in the double ranges. So that is how the credits per hour consumption is calculated inside Snowflake for various warehouse sizes. And whenever we talk about warehouse size, we also have to talk about the per second billing feature of Snowflake. So we know that Snowflake utilizes per second billing feature. So, and also there is a minimum threshold period that is for a 60-second minimum. So let's suppose if I'm creating a warehouse and I have made that warehouse active for the session, and if I'm running the warehouse for, let's say, a very small period of 40 to 45 seconds. So in that scenario, I will be billed for a total duration of 60 seconds because the minimum duration required to be billed for a running warehouse is a total of 60 seconds. That is 1 minute. But let's suppose if I have my warehouse running for the time period of 90 seconds. So in that case, I will only be billed for the time period of 90 seconds and it will not be of entire 2 minutes. So this point is also to be kept in mind that Snowflake utilizes per second billing, but there is a minimum threshold time that is of a 60-second minimum time period. So for example, if we have a 5XL sized warehouse that is running for 2 minutes, it will consume a total credits of 256 credits divided by 60 into 2, which equals to 8.53 credits. So a 5XL sized warehouse, it consumes a credit of 256 credits per hour. So if you go ahead and calculate that, for 2 minutes, a 5XL sized warehouse will be consuming a total of 8.53 credits. Okay, so now moving on. Let's see the auto suspension and auto resumption feature of the virtual warehouses in Snowflake. So this is what we say the automation feature provided to virtual warehouses inside Snowflake. Let's see what does the auto suspension and auto resumption mean. So auto suspend, it ensures that you do not leave a warehouse running and consuming credits when there are no incoming queries. So let's suppose if I have been running some queries on my virtual warehouse for some time, and after that I just forgot to stop my virtual warehouse. So whatever time frame I set, if I set the virtual warehouse to get auto suspended, Snowflake will take care of that feature. Snowflake will automatically auto suspend the virtual warehouse for me if there are no queries running on the warehouse. And similarly, auto resume, which as the name signifies, it is entirely the opposite of auto suspend features. So the auto resume ensures that the warehouse starts up again as soon as it is needed. Let's suppose if my virtual warehouse is in a suspended state, and if I am trying to run a DML query which requires a running warehouse, so in that case, if I have the auto resume feature turned on in my virtual warehouse will spin up automatically and we do not have to go ahead and manually resume my virtual warehouse. So these two features, the auto suspend and auto resume, is a way to automatically let Snowflake do the suspension and resumption of my virtual warehouse. I, as a user, do not have to manually take care of that. So moving ahead, a warehouse can be set to automatically resume or suspend based on the activity. So by default, auto suspend is enabled. Snowflake automatically suspends the warehouse if it is inactive for the specified period of time. So we just have to give in the specified period of time, and once that time period has crossed and no queries have been run on the virtual warehouse, Snowflake will automatically auto suspend my virtual warehouse. And by default, auto resume is also enabled. So Snowflake automatically resumes the warehouse when any statement that requires a warehouse is submitted and the warehouse is the current warehouse for the session. So we have already discussed these points. So this was about the auto suspension and auto resumption feature of Snowflake. We have to specify the time period whenever we are trying to use the auto suspend feature in Snowflake. Both these auto suspend and auto resume features are automatically enabled by default. So based on the user activity, Snowflake takes care of both the things. Okay, so I hope I have made myself clear with all the theories and with all the diagrams. So now let's go ahead and get into the most amazing concept of the virtual warehouse, which is a multi-cluster warehouse. So multi-cluster warehouse, as the name signifies, you might be getting some hints on what is a multi-cluster warehouse. Okay, so let's just get started. Multi-cluster warehouse, it is an additional feature provided by Snowflake in enterprise editions or higher. So we do not have this multi-cluster warehouse feature present in the standard editions. We only have this multi-cluster warehouse feature available in enterprise and higher editions. That is enterprise, business critical, and the virtual private Snowflake editions. Okay, so multi-cluster warehouse enables you to scale your compute resources to manage your user and query concurrency needs as they change, such as during peak and off hours. Okay, so that was the bookish definition. Now let's try to understand that more specifically. So what is a multi-cluster warehouse? So by default, any virtual warehouse, it consists of a single cluster of compute resources for executing queries. And as queries are submitted to a warehouse, the warehouse will allocate specific resources to each query and begins executing the queries. So let's suppose if I have a standard normal warehouse. So whenever the user runs any query, the warehouse allocates resources to the query and begins executing the queries. And if I talk about the positive scenario, like whenever sufficient resources are available to execute that query, it's all a happy and go scenario. So the query gets executed and the user gets the result. But what about if sufficient resources are not available? Like, let's suppose multiple queries are being run against a single warehouse. So what will happen in that case? So if we talk about a normal warehouse, Snowflake will make a queue and put the queries that have to be run in that queue. And once my current running query has stopped executing, the execution is finished for the current query. Queries in the queue will start running up again. So until the compute resources become available to run the consequent queries, Snowflake keeps those queries in a queue, and as soon as the memory is available, one by one the queries start getting executed. So let's understand that with the help of a diagram. So we have a virtual warehouse. We have a single cluster of a virtual warehouse. So let's suppose we have a single query that is trying to run. So it's a happy and go scenario. The query will run as the compute resources are available to run the query, and my query will get executed. But what if we have multiple queries to run and we don't have the sufficient memory to run all the queries? So let's suppose if I have a set of three queries, firstly Q1, then Q2, and then Q3 being the queries, and Q1 is running, which is already taking a huge amount of memory, a huge amount of compute resources. So in that case, my second and third query, which are Q2 and Q3, will get queued. And unless my Q1 has stopped or executed happily, so till that time, Q2 and Q3 will stay in a queue. And once Q1 has stopped executing, then consequently the resources, the memory will be allocated to the future queries, that is Q2 and Q3, and then the execution of Q2 and Q3 will start. So in this case, we get a query, we get a queue in which my consequent queries are getting stored. So that is not a positive scenario. So let's suppose if we have a critical business requirement where I need to run all the queries consequently in parallel. So what to do in that type of cases? If I have to run multiple queries like 10 to 12 queries on a single warehouse on a single data set. So what will happen in that case? As the standard warehouse, it does not provide me that option. So let's see how Snowflake deals with this kind of situation. So with multi-cluster warehouses, Snowflake supports allocating additional clusters to make a larger pool of compute resources available. And this allocation of additional clusters, it can happen either statically or dynamically. So we will get additional clusters, and additional clusters, it automatically means a larger pool of compute resources. So a larger pool of compute resources means more memory to run my queries. So this multi-cluster warehouse, it helps us whenever we have a concurrency of queries. Let's understand that with the help of a diagram. So we have a virtual warehouse, and we know that a virtual warehouse is a single cluster of multiple compute resources. So a multi-cluster warehouse, in a multi-cluster warehouse, we have a combination of clusters, and the combination of clusters here, we have a combination of two clusters, but it can be many. It can be based on the criteria that the user defines. So we'll have multiple clusters in a multi-cluster warehouse. So multiple clusters mean we have a larger pool of compute resources available to run as many queries as the requirement may be. So now what will happen whenever we get a huge number of queries? So let's see that. So let's suppose if I have Q1 which requires some extra memories, so that will be running in a separate cluster of my multi-cluster warehouse. And let's suppose I have two more queries, Q2 and Q3. So they will be running in a different cluster in another cluster, as it is a multi-cluster warehouse environment. So they will be running in a different cluster, and it's again a happy to go scenario. So all the three queries are running parallelly, and we do not have to worry about the concurrency, about queries being queued and taking up additional time, extra time to execute. So in these kind of scenarios, whenever we have huge number of queries, so in those cases, we can enable our warehouse to be of the category multi-cluster warehouse, so that if in future the case may be that my warehouse will be having some concurrency scenarios, so in that case, the queries can benefit from this multi-cluster feature of my multi-cluster warehouse. Okay. So whenever we try to define a multi-cluster warehouse, we have to specify two properties, which are the maximum number of clusters, which can be to 10 and have to be greater than 1, and also the minimum number of clusters, which is equal to or less than the maximum, and also up to 10. So these two properties we have to define always whenever we are trying to create a multi-cluster warehouse. And also a multi-cluster warehouse, it supports all the same properties and actions that a single cluster warehouse supports, which is specifying a warehouse size, or resizing a warehouse at any time, or auto suspending or the auto resume feature in the warehouse, which we have already discussed. So multi-cluster warehouses, they support all the features that a standard warehouse support, and also we get extra pool of compute resources, which helps whenever we might be having the concurrency issues. So let's talk about the benefits of multi-cluster warehouse. So let's suppose if I'm dealing with a standard single cluster warehouse, so what will happen if the query load starts increasing to the point where I just need more computer sources. The computer sources available to me right now are not sufficient. I do need more computer source. So in that case, I have to either increase the size of the warehouse, or I have to start additional warehouses and explicitly redirect the additional queries to those warehouses. So that is a lot of manual effort. I have to first increase the size of my warehouse, and then explicitly I have to redirect my queued queries onto the additional warehouse. And when the queries have stopped executing, when the query load has come to a normal point, so then the resources are no longer needed to conserve credits. So in that case, we must manually downsize the larger warehouse and also suspend the additional warehouses. So a standard single cluster warehouse, whenever the query load starts to increase on a standard single cluster warehouse, these are the things that a user needs to do manually whenever we have a large query load. So in contrast, a multi-cluster warehouse, it enables large number of users to connect to the same warehouse. We don't have to resize the warehouse manually every time. We do not have to explicitly redirect the queries onto any separate warehouse. We just have to enable the multi-cluster feature, specify the two properties, maximum and minimum number of clusters for the multi-cluster warehouse, and things are good to go. So if the query load starts to increase, Snowflake will automatically spin up additional clusters in my multi-cluster warehouse. And when the query load comes to a normal point, or even when the query load starts to decrease, Snowflake will automatically bring my number of clusters down to the minimum number of clusters that I have specified. Okay, so moving on, let's talk a little bit about credit usage of multi-cluster warehouse. So let's suppose, for example, I have an extra large size multi-cluster warehouse and I have enabled 3 clusters for that multi-cluster warehouse. So I have an XL size warehouse with 3 clusters. And if this multi-cluster warehouse, it runs for 1 whole hour, so how much credits will the entire warehouse consume for that whole hour? So I want you to pause the screen right now and just have a look at the question again and think of the answer. So I will drop in a little hint: an extra large sized warehouse, a single cluster extra large sized warehouse, it consumes a credit of 16 credits per hour. And here we have 3 clusters of that extra large sized multi-cluster warehouse running, and all these clusters are running for the whole period of 1 hour. So in that whole period of 1 hour, how much credit will be consumed? So since an extra large sized warehouse, multi-cluster warehouse, it consumes a credit of 16 credits per hour, and we have specified that the warehouse does have 3 clusters running. So in total, it will consume a 16 multiplied by 3, that is 48 credits. So I hope I have made my points clear. Okay, so with that, we come to an end on the whole theoretical aspect, whole theoretical discussion of what is a virtual warehouse. We did cover a lot of points in this lecture, a lot of theory points in this tutorial. So let's just quickly go through what all points we discussed in this tutorial. So we discussed what is a virtual warehouse in Snowflake. We saw the types of virtual warehouse. We saw the additional size feature that is provided for every warehouse in Snowflake. We also had a look and understanding on the auto suspension and auto resumption feature of any virtual warehouse. And then, most interesting topic, we saw multi-cluster warehouse in Snowflake. We saw the need of multi-cluster warehouse, and we saw how does multi-cluster warehouse supports whenever we have a query load, an increased query load, or a concurrency of queries. In those scenarios, how we can leverage the benefit of a multi-cluster warehouse. We also saw how credit consumption takes place in multi-cluster warehouses. Okay, so if you watched the video entirely, I hope that your perspective on virtual warehouses in Snowflake was made absolutely clear. So this was entirely theory discussion. It was entirely theory based. So in the next tutorial, we will see how we can create virtual warehouses in multiple ways. We will see how we can create warehouses from the Snowflake interface, and we'll also see how we can create virtual warehouses using SQL. So the prerequisite will be a basic SQL knowledge like create or select statements, and we'll also see how we can set the properties for the virtual warehouse like auto suspend, auto resume, how we can create multi-cluster warehouses, and how we can set the maximum and minimum number of clusters for any multi-cluster warehouse. Okay, so stay tuned to the channel and make sure to subscribe. I will see you in the next Snowflake tutorial where we will be covering these points, how to create virtual warehouse. And that was it for this tutorial. I will see you in the next video.